Monday, and we just need to find the missing angle. What do they need to add up to? 180. So I just do 70 plus 40 is 110, and then I take 180 minus 110, and I get 70. Raise your hand if you got it right. Good. I should see everybody's hand at this point. Identify the relationship between the angles. When we identify the relationship of these, I always highlight my parallels. And then I decide where are my angles in that parallel. Are they interior or exterior? They're exterior, and are they on the same side or opposite sides? So you need to say that they are alternating exterior angles. And what happens when we have alternating exterior angles? They equal each other. How many of you got all of that? You have to have all of it if you don't. How many of you just have alternating exterior angles? Okay, get that they equal each other also on there, okay? Number 3 says to make a dot plot of the table. Okay, these are our numbers, and this is the frequency. Oh, okay, thank you. My lowest number is a 42, right? And my highest number is a 48. So really, my dot plot could just consist of that if I wanted to. So I'm just going to show an example real quick. So this is 42, 43, 44, 45, 46, 47, and 48. Now the frequency, it would be your X's on there. So at the 42, one frequency, I'm just going to put 1X. For 43, I have to put, and you could use dots if you would like, because this is dot plot. Dot plot could be dots or X's. You'll see it both ways. And then 44, how many do I put on 44? How many do I put there? 4. You can't just put, like, think this is a 1, this is 2, this is 3, this is 4, and just put one dot there. You have to have all of the dots. Does that make sense? Garrison, do you understand that?
Yeah.
Okay, so go ahead and fix that on yours.
Okay.
45, we go up to 5, so 1, 2, 3, 4, 5. One thing when you create dot plots using X's or dots, you want them to be about the same size. So then if you have to read that dot plot, you can read it easily. 46, I do 4, 1, 2, 3, 4. 47 is 2, 1, 2, and 48 is a 1. Looking at this dot plot, do we have an even distribution of numbers? Pretty much, yes. Because we go up and down at the same. So is there really an outlier on this one? No. So if I want to find out central tendency, I can use the mean or the median. I could use either one. Number 4. Jan surveys all the people sitting near her at the lunch table. What kind of sampling method is this? Does anybody have a guess on this? Anybody have a guess? You can have a guess. I don't care. You probably don't know the answer.
I don't know what how to say the word. It has
Spell it.
I don't know if I spelled it right though.
You just spell it. I bet I can figure out what.
S-Y-S.
Systematic? No.
Yeah.
Nope, it's not systematic. Because systematic would be like every 4th person or every 5th person. What's your guess?
Cluster sampling?
Close, not quite. It is a cluster of people, yeah. It's not random because she's asking the people next to her. It's convenience. And we haven't had this one yet. That's why I said you guys are probably kind of guessing. Convenience sampling. Convenient means it's what? If something is convenient for me, it's easy to get to, right? So she was just asking the people at her lunch table, so was that convenient for her? She didn't have to get up, right? So you're gonna write convenient sampling is a sampling or a sample taken from a group bless you, of people easy to contact or reach. So this is just a new term that we have, and you guys wanna write down that definition so you have it in the future to look back at. We're gonna take some notes on number 5, because I want you to be able to know how to read. What are these called? Do you guys know what these are called? Okay, box and whisker, right? We're gonna label what it means. So we're just gonna draw one. This dot here would be the minimum score, or your lowest score. This right here would be quartile 1, not quarter 1, quartile 1. This here would be the median. And that number right there would be quartile 3. And then this last dot would be your maximum number. So my questions are, who has the best median mile time? So right here is the median for Jamal. Right here is the median for Tim. Yes, there are not numbers up here, but don't you just use the same numbers as below? Yes. So who has the best time, Jamal or Tim? Tim. When you're running, you want a smaller time. You want the shortest time. So you want to write down for part A, it is Tim running. You want the fastest time. Just kind of like in swimming. In swimming, you want the fastest time, right? Cross country, fastest time. Any kind of running, you want the fastest time. Is there anything else in sports-wise that you might want your fastest time? Like you want the lowest score? Golf. Golf, you want the lowest score. Mine never is the lowest score though, so. What else do you want the lowest score in? What about just NASCAR racing? You want the lowest score? You want the fastest time, right? What about bowling? Do you want the lowest score? Nope. Nope, you want the highest score. What about in track and field, what about shot put and discus? Do you want the lowest score or the highest score? You want the highest score, because you want it to go the furthest. Just kind of like the long jump. Do you want the shortest jump or the longest jump? Okay, so you got to think about those things a little bit when you go to answer these. And part B says, who is the most consistent or the more consistent runner? When you answer this question, you're focused on the box part itself. The smaller the box, the more consistent you are. So who has the smaller box? Who? Okay, so then part B is Jamal. Jamal, and we're just gonna write smaller box. Smaller box equals most consistent. Number 6, for the spinner, which is the most likely scenario? Jim wins. Well, before I actually do some of this, I kind of take my spinner and let's see here, that, you can't what fraction would this be about? What? 1/6, cause see if I just keep drawing it here. So that's what you kinda have to figure out first, that this is about 1/6. So Jim wins 4 out of 9 spins. Well, he wins only 1 out of 6. So does 4 out of 9 equal 1 out of 6? No, 4/9 is greater than a half, right? So that's not gonna work. Jim loses 7 out of 15. Can he lose 7 out of 15? 7 out of 15 is about what? Isn't 7/15 about 1/2? Can he lose about 1/2 of the games? Yeah, because I can lose more than that, right? Because I can lose up to 5/6. So which one is most likely? Losing 7 out of 15 or winning 4 out of 9? It'd be 7 out of 15. Then it says place the probabilities of the spinner on the probability line below. So my wins, we said, was 1/6. So if this is a half, I can split my whole thing into 6 if I want. So this is like 1/6, 2/6, 3/6, 4/6, 5/6. Are you with me on that? So my wins would be here at 1/6, and my losses would be at what fraction? Well, what's the other fraction? 5/6 would be my losses. You want to make sure you split that into the fraction. Jane conducts an experiment and tosses a coin 40 times. She gets heads 30 times instead of the expected 20. What could be the reason for the difference? So really, your expected is 20 out of 40, right? And that would be my, is that experimental, the 20 out of 40? No, 20 out of 40 is theoretical. Because theoretical is what you expect to happen. So then her 30 out of 40 is my experimental probability. You gotta know those terms, write those down. No, that one's the theoretical and one's the experimental. Could it really be that she miscounted? That's really never gonna be an option. She needs more trials. Could be, right? 40 times isn't. She needs a different coin. Is that ever gonna be it? No. She got 30 and that is close enough. Is that really close? Not really. So what happens is that she really needs more trials.